in case the class lecture schedule is behind the syllabus schedule, the GA will adjust the due date for your homework and others. Okay? And also, I'm trying to put any announcement over here. So if you, in case you are late, you don't have to ask everything. So what's the homework and it's your responsibility to catch up. As you know, we have a pretty much big classes, so it's not elementary school. Okay, so you are pretty much I think the adult enough to take care of yourself. So. Today we are going to continue the lecture for the chapter 1, which is the introduction of the computer and operating system by the next week. And next week, so we do not have class on Monday. So if you want to, you can study by yourself in the classroom. It's up to you. But anyway, there's no class. I will not be here. So it's a Labor Day. Then followed by the exercise lab. It's the first exercise lab, but not for only the operating system. Is that we are going to set up the cloud computing environment for that will be used for throughout the semester using Google Cloud. So at the time, please bring your own laptop. Okay, fully charge it. I don't think we have enough the outlet, but I will try to. Yes. So I'm going to ask the department to bring our GA to bring the outlet, power outlet, but please the fully charge it. So you're, on Wednesday, why don't you contact Omar? I'm going to email to him. So bring the power outlet. So because we have too many students to use the power outlet, so 2 or 3. You can ask the Arafat or the Oman. Okay. Tomorrow. Okay. Then at the time, we will set up the Google Cloud computing environment, including the activate your coupon. So we got the grant $50 for each student. That's not pretty much enough if you use a lot. But I think the full exercise lab and your project and the study in this semester, I believe that's pretty much enough. So. And first homework due is the next week, the Friday. So this is the first and last time to announce the homework due. It's every week. So please check any due date on Canvas so you can check it. And also there might be the announcement in the first page of your Canvas, so you may realize which one is due. Yes. Question?
If my computer actually can't take the battery, needs an output all the time. Is it okay?
So you can take care of your computer, okay? Do not ask how can I manage the battery or anything. So please do find your own way to keep alive your computer, okay? You can bring the battery if you want, okay? Or borrow your computer. Anyway, so some of the students already asked, do I need the very high-end the computer or the PC or laptop? No. So as long as you are able to connect to the internet, it's pretty much enough because we are using the cloud computing. Okay. So the last class we talked about this one. What is this? This is computer. So computer is the main thing that we are dealing with throughout the semester. Not only this class, any subject in computer science and computer we are dealing with this one. So this device, this computer has the 3 main components as we discussed. One is CPU, processor. Another one is memory, or RAM, or it's a secondary storage, mostly hard disk drive or solid state disk and so on. Nowadays, we use the memory or such a memory for hard disk drive. But anyway, this is a basic, the really basic architecture of the computer. Then they are connected through this is how they communicate each other, how they transfer the data using it's a bus, okay? So there are different, it's the I/O bus, and they are connected. Then using bus, they can send and transfer, receive the data. Okay, if you go back to the undergraduate class, a lot of things that we discussed, you already learned in the undergraduate classes, like the embedded system, or what else, the data structure class or assembly class. In there's such a class you learn. The bus is nothing but the wire to send the electronic signal. Okay, we have wire. So, for example, 4 wire. So if you send the signal, as I said, we can create such an electronic signal. Then we can use represent this one as a 1, this one as a 0. So if we send the 1, 0, 1, 0, so that represent the decimal is a 3, something like that. Using this, the mechanism, if we code, if we make the agreement like that, for example, this is the L, and the 1011 is the E. So we can represent something, the word, and so on. So this is how the computer is working. So using the bus, we can send such a signal. This is a basic computing architecture. And plus, in addition to that, there are many other devices like the mouse and the peripheral, or the monitor, I/O devices. Okay, if we consider any attached device to the computer as an input and output, any device are regarded as I/O devices. So sometimes we call this and these other as I/O devices. So this is the overview of the computing architecture. Then let's think about this one. This is a power. Okay, as we have seen the last class, this is a computer. A modern computer means it's an electronic device, which means it needs the electronic power. That's different from the old style of computer or calculator. That uses just the gear or the human power, but this one uses electronic signal, electronic power. So which means we need to connect this computer to the power. Then, what happens when you connect your computer to the power outlet and turn on the button? Then what happened? Anyone? What happened the first when you turn on? Booting. So or the starting your system. So when we are saying the boot, so what does it mean? Booting. Boot what?
The OS.
So this is the what? Hardware. Hardware without power and even without any management. It's nothing dummy, the device. We cannot do anything. So we need to operate, we need to do something. So first, especially computer system, when you turn on your computer system, the first thing is we need software. Anyway, we need the software. Hardware itself, it cannot do anything. So it needs the software. So there is the first program when you start your computer, which is called BIOS. BIOS is also
basic input-output system.
It's an operating system that we are going to deal with, believe it or not. So that is the first operating system, and also first the software running when you turn on any computer. When you turn on, it's the started. It's also operating system, really. So BIOS program. Let's started. What is the main job of the BIOS? Initial application, for example. So to use such an application or other operating system that you already know, first we need to check. For example, when you come to you are the management of this building. So every morning you need to do is check which class is open. No, before that, whether this building is safe or not, and whether there's a new equipment. So first turn on the light and check. Okay, whether you have enough seat or whether there's a broken the chair or not. So BIOS program, because we have a lot of the devices connected to this one. Sometimes new ones, sometimes broken, sometimes something. So BIOS program first check all the devices connected to this computer. Okay. So that is the main job. That plus, as he suggested, BIOS program is a very little tiny program. It's an operating system, but that's it. So just to check the hardware devices, yeah, nothing the BIOS program can do. Instead, it can start the other operating system because it has the bootstrap. So it has the location of the operating system that you are going to use. So that is the reason. Nowadays you may not realize such a thing, but inside, several years ago, so at the time I'd like to use the Linux, plus in addition to the Windows. So, which means I'd like to use the dual operating system. What I did at the time is I installed the operating system, the Linux operating system. I installed the Windows operating system. Whenever I start the computer, my system, I need to select,
Which one?
okay, the either operating system or this one. For example, if we are using the Linux, or the Linux-based operating system, it's called the Lilo or the group, GRUB. I forgot the name exactly. I will show you. So there is a program like the Lilo or such a program. If we are using the Windows-based system, anti-loader and stuff like that. And still, from time to time, if you turn the forcefully off and turn on the Windows system, there is something option to select, right? The safe operating system or something. It's the same thing. So that is a part of operating system. It's called the bootstrap. It has the selection of the operating system. It doesn't keep entire operating system. Instead, location of the operating system. Where is that operating system? Somewhere in your hard disk drive. Why? Because it's big. It doesn't fit to the memory or the CPU. Also, these are the volatile, so it will be gone. So to permanently keep the data, we keep the operating any computer program belongs to stored at the hard disk drive. So this BIOS program has the location of the operating system. Then finally, it can start the operating system. Then so there are I quickly overview is the computer architecture, but it's fun. If you do not remember, it's a good idea to remind such the basic computer architecture by checking your old textbook or even Google or the wiki. Please remind such a thing. And then where's that BIOS program? Where is it stored? Here, hard disk drive?
Yeah.
You cannot use a hard disk drive until you start your operating system, right?
Onboard ROM?
It's somewhere memory, okay? You cannot use a hard disk drive until you start. It's somewhere in your memory. It's called the read-only memory, ROM, and for example, EPROM and something other. It's a special, the different types of the memory. Most of the general memory lose the data without power. However, there are different types of memory like the EPROM and the read-only memory. Even though you turn off the computer, but still data existing. It's a firmware, which is called a firmware device. So from time to time you heard about the firmware. Firmware is the software also. It's a software like your program, but it's in the memory. Okay, then it sometimes is considered as a part of hardware. Any hardware needs a software. Any. Okay, without software it doesn't run. Okay, so we need such the hardware and software to operate that. That is called the firmware. Okay, then this BIOS. Sometimes if you click push the button F2 or F8, so you can enter the BIOS program. Then there are several options like the different types of setting of the CPU or processor, or you can sometimes you see the booting order. Booting order means in case you have the several different operating systems, then you can, it is true, you cannot start the operating system, multiple operating systems same time, always one. Okay, but when you have the many operating systems, there might be, you can specify the order. If the first one is not available, second, third. It has been used a lot, long time before, when we use the multiple operating system. But nowadays, we don't care. Why? Using virtual machine. We will see what is the virtual machine. You already use, many of the students already use virtual machine. Machine is inside the operating system. We consider other operating system as a part of software. But it's a virtual machine. The hardware, it doesn't exist. It uses the only same hardware, but through the operating system. That is because of that, so we don't care a lot such a much the bootstrap, but it still exists. You can use. So then, after specify the operating system, I said the operating system is started. What does that mean? Starting operating system. Start. What happened when you start the operating system?
Action program is loaded into RAM.
Excuse me?
Action program is loaded into RAM.
He said load the program into the memory. That's starting of your operating system. Why? Because operating system is also software.
Faster.
So software should be accessed, used by CPU. Okay? What is a program, by the way? Operating system is also program. And the application program is also program. So anything, any software you are using with your computer is a program. What is a program?
Interface between
It's
user
a-
and hardware.
Actually, if you open, I'm not sure whether you can open. If you see the inside of the program, it's nothing but bunch of set of instructions that we discussed. Last time that we talked about what is a CPU. CPU can process the only operation. Okay, actually operation is the instruction. I'm sorry, the instruction. So instruction is kind of the agreement to the computer and the user. So this CPU can process certain operation, then coded by the something assembly language, for example, move or the increment and the substitute and the such a defined operation. Then this is called the instruction. This CPU can process only this instruction. Then this program has bunch of sequence of this instruction. So, however, CPU, as we have seen the last time, CPU can access the data or operation only from the memory because of the speed gap. It's too slow. So, first thing we need to do when we are saying the starting operating system is load this operating system software to the memory. Okay? This is called especially for the operating system, it's called the booting. But in other words, we are going to create the process. So especially the operating system process is called kernel process. So from time to time you heard about my kernel has problem. Kernel is very basic. The starting kernel process, rebuild the kernel. Kernel means it's a operating system process. So first process. The process started. The first process is a start. So it's very hard to recognize, identify. So we number. This is a number 0. What some of the operating system use? Number 1. It's a number 1 process. So process ID is 1. Number 1 process will be loaded into the memory. Load means it's just copy using the bus to the memory. By the way, what is the memory? In terms of data structure. Not hardware. I do not know much about the hardware. Anyone? Yes. Address. In terms of data structure, memory is nothing but bunch of address. That is the reason whenever instructor or professor they explain about the memory or something similar thing, they use such a thing. right? 0, 0, 0, 0, and this is FFFF, and the 0, 1. So you can. So nothing but set of address. For each address is actually grid style using the electronic signal. We can represent what? 0 or 1, right? 0 or 1. So we can, if we can represent the 0 or 1, we can do anything, right? As we have discussed last time. So then, if we know the address, so address is how many? Such a location. So using address, so we can access that data and bring that data. For example, if CPU call the specific data in the address 0000, then this data will be returned to sent to the transfer to the CPU using voice. Same thing between the memory and the program. So when we start BIOS program, start the operating system, that means it has the location, because CPU memory doesn't do anything, there's no address, but this one knows the location of the operating system. The data of program of that the operating system will be copied, transferred to the memory. Usually when we locate the kernel first process in the memory, we use the lower address. That's the easy to manage. Somebody said it's also efficient, but I'm not sure. But it's the more convenient way to locate the first program. Then that is the kernel program. That is the starting of your operating system, starting your system. Then next thing is this main job of this kernel process. The process ID number 1 process, or the operating system process. There's a lot of things. No, it cannot do anything. The main job of this process is to create another process. So this is the first process. Then this is the process or the parent of other processes. So for example, I need something function. One of the function of this operating system is the I/O management. Then create the process, child process. Okay? Then that will be I/O job, and swap, and the network, and so on. So this kernel process will create another process, then assign the number 2, 3, 4, 5. Then this process will create another process, so it looks like the tree structure. So process, or most of the operating system uses such a tree-based structure to manage it, to create the process. By the way, what is the process? Professor Lee mentioned a lot. The creating process, child process, parent process. What is the process?
Instruction. It's instruction?
It's also instruction, because we copy the load set of instruction to the memory, right? So it's also instruction, but it's different from program. That means process is the instruction where? Memory, loaded into the memory. So whenever you create the process, or whenever you start the program, double click or command line, okay? So that is the starting of your program. After that, the process will be created. Creating process means copy instruction, set of instruction from the secondary storage to the memory. That action, that thing is called the creating process. So process itself is the data structure in the memory. Okay? It also should be organized. As you can see, it's nothing but the address only and the 010101. So that should be organized. Organization means always data structure. It's a formatting. So process, each operating system has a very the details, the structure of the process, like this one is the text, this one is the program, this one is the stack and the queue and so on. So we keep such an instruction So here we will see details of this one later. Then the sum of the data is temporary data, right? Sometimes we create more space on the memory, like for example, if you define the array in your program. Array is the space where the variable, where you can keep a lot of data. Where is it? The process data structure. Okay? So this is defined by what? Actually, it's dependent on CPU. Okay? Because the CPU needs the data from the process. Then operating system consider. So that is the reason, even though you have the same program, same task, but if you are using different the CPU processor, you need to compile it again. Why? Because each CPU has different process structure. Okay? So this is the process, and this is the creating process. So first part of the operating system, pretty much half of the operating system regarding to the process. So we will learn how to create the process, how to manage the process. And is there any issue? For example, how many processes? There are so many processes. How many CPU we have? One or very limited. If you are even though you are using dual core, the multiple processor, but still very limited. Less than the number of processes. So which means there is a competition. So we need to solve. Or not only the competition, but if the two processes access the same data, so there might be the problem. So we will take care of such issues in the process. This is called the process management. First, the half of the semester, we will talk about this process management. For example, in your project 1, what is the title of the project 1? Do you remember? You are going to create the shell programming. Shell programming is for example, when you access, if you try to use the computer-based system, you need to log in. Okay? What happens when you log in the computer operating system? What happens? There might be something interface like the desktop, or if we are using the Linux, it's the desktop environment, GUI or genome. Or even sometimes you can access your operating system using command line interface, like the SSH or teller, okay? Whatever method. You need to use the interface to use your operating system. Actually, this is also process. This is also process created by one of the process in your operating system. So the process that acts as interface between user and your computer, this is called the shell program process. Shell process, shell program. Okay? This one is the last one, end of your process tree. Then using this one, you can access the functionality and resources. So this is also process. You are going to create this program in the project 1, because managing the process is one of the biggest job, most important job of your operating system. Okay, then this is the first step. Then next, once you create the process, in other words, the instruction program are loaded into the memory. So we have the process, kernel process, and the process 1, process 2, many processes. Over here, do we have enough space here? As we discussed last time, memory is faster than the secondary storage or hard disk drive. However, it has the drawback of relatively small size. Okay, which means, is there anyone who satisfies your computer, laptop? No matter how much expensive your computer is, I don't see any student or user who satisfies their computer. One of the main reasons is the less memory, right? So which means, in other words, you not only your operating system intentionally create a lot of process, that will be faster, right? So if we think about the Windows system is, in terms of computing architecture, Windows system is not the very good operating system, one of the horrible, really bad. We will see why throughout the semester. Sometimes they throw away the command line interface and get back to the batch, and so always messed up. So to hide such a bad performance of the Windows system, Windows usually load a lot of process and service and the program into the memory when you start them. Also, then starting your operating system will take a time. So first start the basic, then the behind it, keep starting the service, and if you check your task manager, usually 200 process are running. How many of process are you using? I think the 1/10, few of them. So that is the reason there are a lot of the wiki site and Google, if you are doing the Googling, so how to optimize it. Then most of them, we disable the services. Okay? So why? Because the memory, if we load the program to the memory, it's faster to use that. But not all of them are used because due to the small size of the disk memory. So the next job is for better performance of your system, we need to manage the memory. Okay. So second part of this semester, we are going to do the memory management. Okay. So the next, what is this? This is the I/O devices. So we have the input and output. Hard disk drive is just one of I/O devices. What else? Mouse, monitor, and sometimes the touch screen, keyboard, and so on. So and sometimes we can use USB. By the way, USB is only for the memory stick. What does that mean? It's a universal serial device. Actually, this is not only for the memory stick, but it can be used in many of the things. Sometimes you use lamp. You mean the lamp or lamp?
Lamp.
The lamp. So it can be used for the network and anything. It's a universal serial port. So, for example, I found the one simple the USB device is a lamp. You can use power only if you want a light on. So for using the USB. So USB is a universal. Why? Because any device in your computer system, okay? How does your computer recognize your device? I/O device, mouse and everything, how?
Through the driver.
Actually, there's no way. Each device has their own data structure. Okay? Data structure means, as I said, this is I/O device, which means we have a data to transfer. So, depending on how to transfer. So, each device has a different. Sometimes it's a serial, sometimes the other.